What is a system of equations? Multiple equations for sure, right? Usually they do have variables. They sometimes have patterns. What do they have though? An ordered pair as a solution, right? So if we're talking about linear functions, it's definitely an ordered pair, and it's where the two lines cross, right? What if it's a system that looks like this though? Is it still an ordered pair? It's an ordered triple, isn't it? Okay, it's an ordered triple, and it's a point still, right? In what kind of space? Three-dimensional space, right? Okay, so yesterday we talked about substitution. We got one of the variables by itself and substituted it into two other equations to get a smaller system, and then we solved for one of the variables and substituted it in to get a point, right, part of the point, and then substituted that answer in and substituted that answer in to get the whole point, correct? And that was called solving the system by substitution, okay? So today what I want to teach you is how to solve a system by elimination, okay? The fun part about elimination is that we get to become variable assassins, and it's legal, okay? Partially because we're not actually killing anything, because the whole killing thing is where it becomes illegal, okay? That's something we should not do, right? Even if you don't get caught, it's still illegal, okay? So I started off with an easier problem. Why do you think this is considered an easier problem? Right, the middle one is missing a variable, right? So here's what we need to think about. If we're eliminating a variable, that means we're getting rid of it, right? We're getting rid of a variable. This equation already has a variable gotten rid of, right? It only has two variables. So that should give us a hint in a problem like this which variable we should try to eliminate. Because here's the deal. I have one equation with y and z. What do I need? I need another equation with y and z, right? If I have one equation with y and z, that's two variables. And if I have two variables, I need two equations, okay? So one equation with y and z, I need another equation with y and z. But if I eliminate x, don't I have another equation with y and z? Give them to David. Okay. Yeah, not the scene chart, but the textbook pages. Yes. There should be 3 pages. Thank you. Okay, so let's look at this, okay? Sometimes this is actually called solving systems of equation by combinations, okay? I prefer elimination because then I get to be a variable assassin, okay? But what we're going to be doing is combining two of the equations. And in the process of combining the two equations, one of the variables is eliminated, okay? Sometimes it's just automatically eliminated. Sometimes we have to do some covert activities because, you know, we're assassins and all, right? Okay. So in this case, if I combine the top equation with the bottom equation in an attempt to eliminate the x's, will they actually be eliminated? Because 2x and x is 3x, right? So what does it seem like I would have to add to 2x to make it become a 0? Negative 2x. Does that make sense? Okay. Now, as assassins, we are allowed to do things to one or the other equation. And when I say do things, I'm not talking about torture. I'm talking about multiplication. Okay. Division is also allowed. We just don't hardly ever do that. We usually do multiplication. Okay. We're allowed to do multiplication to a whole entire equation or to one or both of the equations to make one of the variables eliminate. Okay, so do you think that it would be okay if I multiply the entire equation down here, the third equation, by negative 2? Because I haven't written anything down yet, but if I multiply this by negative 2 and add it to this, won't it go away? Won't it be eliminated? Okay, so first thing that we have to do is we have to eliminate a variable. Okay, we chose to eliminate x because this one already has x eliminated from it, right? So I'm going to write this equation right here, 2x minus 2y plus z equals 3. And then I'm going to multiply this third equation by negative 2, the whole equation, and I'm going to write it right there. You okay with that? So negative 2 times x is, good, negative 2 times 3y, negative 6y, and negative 2 times 2z. Now I'll tell you this, if people mess up, it's right here, because they write equals negative 21. Because they remember this and this and this. Sometimes they forget these two, but they for sure remember to multiply this one, right? Because that's the kind of important one. But then the longer they go, the more they forget. And once they get here, they just totally forget. But you're not going to do that, are you? 42. It would be a crime, and we're already assassins. We don't need any more crime. Now we're going to combine these two equations. Now, some people earlier said, so are we adding or are we subtracting? Well, we're combining. Okay, I don't want you to think of it as adding or subtracting. I'm taking this term and putting it together with this term. So what is 2x and negative 2x? That's 0. That's eliminated. What is negative 2y and negative 6y? Negative 8y. So if you want to be technical, which one of those operations are we actually doing? We're actually adding, aren't we? Okay, we're actually adding. But if we'll think of it as combining, then we're not worried about do we switch the signs or whatever. Okay, so what's 1z and negative 4z? Negative 3z. And what is 3 and 42? 45. So now I have one equation with y and z from the original, and then I just got another equation with y and z over here. Okay? So I need to know how much work you need me to show you. You want to see all my work here at the beginning? Okay. And then as we do the second example for sure, is it okay if I show you what steps it's okay to skip? Is that okay? Okay. So right now, what I have is this equation, and then I have this equation. So I'm going to go ahead and write it down right here, because this is my new system, isn't it? Okay? Now, I have to start over. Start over. I need to eliminate a variable. Guys, do you see why I'm eliminating variables? If I eliminate variables one at a time, at a certain point, how many variables am I going to have left? I'm going to have one variable left, and I'll know the definition of that variable. I'll know the value of that variable, right? Okay, so start over again. Which variable would you like to eliminate? So number 1, does it matter? What's the answer to that? Yes and no, exactly, okay? Because no, it doesn't matter which one we choose, but one might be easier, okay? What if we were going to eliminate the y's? What would we have to do? The goal is to have the same number and opposite signs, right? So opposite numbers, right? So what's the number I would have to get to here? 40, right? So I'd have to multiply this by 5 and this by 8. Guys, some people will choose this one because of the fact that they're already opposite signs. And that's okay, right? But what would we have to do if we're trying to eliminate the z's? Multiply the bottom one by negative 3, right? Because 3 is the number that I want to get to, and I need to get to opposite signs. Why is it pink again? That's super weird. Okay, whatever. So if I multiply the bottom one, what'd you say the bottom one by what? Negative 3. Is it okay if I write these down here? I'm going to pull this one down here. Negative 8y minus 3z. I didn't do anything to it, so I'm just rewriting it. But now I'm going to pull this one down here, multiplied by negative 3 already. Is that okay? So negative 15y plus 3z equals 93, right? Now I combine them. Negative 8y and negative 15y. Negative 23y. Negative 3z and positive 3z. That's 0. 45 and 93. 138. Good. Oh, look. Now I get to solve for y. Y equals negative 6. Now that I know what y equals, where should I go? Like back up here? So you probably want to go back just a little bit. Now in this particular case, I know that this equation is the one from the original, so that I understand what you're saying. But we want to go back just a step to this system, right? One of these two, and probably we're going to choose the bottom one. Why would we choose the bottom one? It's a little easier, right? Okay, so if I say 5 times negative 6, minus z equals negative 31. Guys, what's the easiest way to mess up right here? The easiest way to mess up right here is if I say 5y minus 3z equals 45. You see what I'm saying? That's why I purposely went 5y with my thumb minus z equals negative 31. Like I'm telling my eyes where to look because I don't want them jumping around on the paper. Okay? So negative 30 minus z equals negative 31. So by adding 30 to both sides, I get negative z equals negative 1. Dividing both sides by negative 1 gives me z equals 1. And now I know what z is. All I have left to figure out is x. How am I going to figure out x? So this is where we go all the way back to the beginning, right? Okay. Which equation do you want to use? So we have two choices, right? Top or bottom. Either the top one or the bottom one. Why do you think people would choose the top one? Because of the last number, right? Okay. Why do you think people would choose the bottom one? X is by itself. Exactly. Okay. Which one do you choose? Bottom. Okay. So x minus 3y, so 3 times negative 6, plus 2 times 1 equals negative 21. What? Thank you very much. I even put my thumb there and I still wrote the wrong sign. Good catch. X minus 18 plus 2 equals negative 21. X minus 16 equals negative 21. So adding 16 to both sides gives me negative 5. Is that my answer? No, absolutely not. What is my answer? Negative 5, negative 6, 1. That is my answer. You okay with that? You want to do another one real quick? Okay. Let's do this one. X plus 4y minus 6z equals negative 1. And 2x minus y plus 2z equals negative 7. Negative x plus 2y minus 4z equals 5. Okay, ready? Which variable would you like to eliminate? Think about it for a second. How easy is x going to be to eliminate? See, here's the difference though. Last time we had one that was already gone, right? So if I eliminate a variable, how many variables will I have left? 2, right? So guess what I'm going to have to do this time? I'm going to have to eliminate a variable twice, right? So think about this. Super easy to just combine the top and bottom to get x to eliminate, right? But isn't it also just as easy to multiply this one by 2 and combine it with this one to get x to eliminate? But couldn't I also multiply this one by -2 and combine it with this one to eliminate it? That's pretty easy, right? What about y's? How would we eliminate y's? Somebody tell me one way. Multiply the bottom by -2 and combine it with the top one. Good. What's another way? Multiply the middle one by 2 and combine it with the bottom, right? And also multiply the middle by 4 and combine it with the top. So there's 3 different things we could do. I only need to do 2, right? What about this one? Middle by 3, combine it with the top. Middle by 2, combine it with the bottom. Top by 2, bottom by 3, -3. Yeah? Okay. Which one do you want to do? Which one seemed the easiest? X. You okay with eliminating the x? So first of all, you ready to see what steps it's okay to skip sometimes? What if I combine the top 2 equations in my head? What is this? That's 0. What's this? 6y. What's this? 10z. And what's that? 4. You okay with that? Okay. Is the next one going to be as easy? Probably not. Okay. So which ones do you want to do? I already used top and bottom, so I can't use top and bottom again. Middle and bottom, because they're already opposite signs, right? And I need to multiply this one by a 2. Okay. So I could write it right here. -2x plus 4y minus 8z equals 10. Is that right? And then combine it in my head. 2x and -2x. That's 0. -y and 4y. 3y. 2z and -8z. -6z. And -7 and 10. 3. So I chose a variable to eliminate, which was x. I eliminated twice, right? Now I need to start again. Choose a variable to eliminate. The y would probably be easiest in this case. And I need to do what? Multiply the bottom by -2. When I do that, I get -6y plus 12z equals -6. Correct? Combine. 2z equals -2. Thank you. If I divide both sides by 2, I get z equals -1. Look at all the work I just did. And I just already found a variable because I did stuff in my head instead of writing it down. If you need to write it down, write it down. Okay? What do I do with the z? Into one of these, right? Say over here. So maybe 3y minus 6 times -1 equals 3. So 3y plus 6 equals 3. And subtract 6 from both sides. So 3y equals -3. So y equals -1. And now all I have left to find is x, right? So go back to one of the original equations. Which one do you choose? So x plus 4 times -1 minus 6 times -1 equals -1. X minus 4 plus 6 equals -1. X plus 2 equals -1. Subtracting 2 from both sides gives me x equals -3. -3, -1, -1. Got it?